Thanks, Rod. A big hurt in the around Chatham, Kent there.
Oh, good.
Yeah.
Excellent.
So this session is being recorded so that we will be able to watch this later. We'll be up on YouTube, those kind of things, and on our blog. So let's get started.
All right. Good afternoon, everyone. Okay. Yes. Sorry, I got confused for a minute. So, good afternoon and welcome. We have a couple of questions just to get you thinking, and also to let Heather kind of know what you're thinking about and where you feel your level is. So, how comfortable am I prompting students to think about math during play? So I'm not sure how to help. I understand about math, but I'd like to have more ways to help infuse this into play. And I know how to infuse math into play. So if you could use the, what's the thing at the top, the annotate, and lots of you are finding them. There's stamps you can use. There's check marks you can make. I think we've had some people even learn how to text and use words. So type some words in. So use whatever you're comfortable with. Check those off for us. Okay, got lots in the middle and a couple on each side. Excellent, thank you.
Perfect, we want to welcome you to today's session on intentionally infusing math thinking into play. Thank you so much for joining us, and we truly appreciate you taking the time out of your busy schedule to come and learn with us. Before we begin, we'd like to do our local territorial acknowledgement, which we do before all of our sessions. We acknowledge that the land on which we are gathered is part of the traditional territory of the Chippewa, Odawa, Potawatomi, and Delaware nations.
Okay, and during this session today, here are some of the things that you'll be hearing about and learning about from Heather and also from Jen and her students. So Heather will first define what additive problem types are, and then discuss 4 different types of additive problems and 1 equal groups problem. She will also talk to us about how to progress our students emerging how many skills to addition and subtraction. We will hear Jen working with the students in her classroom as she extends their counting to different mathematical situations. We will also learn about what to try. So for those of you from Lambton, Kent, our where to next. What do I need to do when a student has answered a question either correctly or incorrectly? And we'll learn how equal groups problems extend counting skills to multiplication and division. Yes, we actually, with the equal groups problems, we get them started thinking in multiplicative ways.
That's a lot.
Yeah, it is a lot.
Let's get her done. We can do this. I believe in us. We can do this. So the content from today will be archived on our blog, which is lkdlempro.blogspot.com. You can go there and you can get all the content and lots of content that is basically videos that have strategies from the loss and continua, but also it has all of the 3 sessions that we've done. So we've done subitizing, counting, and now problem types. So it's a way to go get that content later and be able to share and learn from that together. So please engage with the blog. That's a great resource. But probably the most important thing is to say welcome. I want to say thanks for being here. It's a busy time when we're during midweek, and we were just chit-chatting about the fun of kindergarten in Southern Ontario. It's a mud garden. There's lots of mud happening, and we know that at the end of a busy day that to take time out to put aside some time for thinking and reflecting and kind of preparing, we appreciate that. So thank you so much. It's really appreciated. We have a big welcome. for the one, the only Heather Wark, coming to us from the shores of Lake Superior, Thunder Bay. I was going to say put your hands together, but it will be very quiet, the clapping. There's only a few of us in one room.
There you go, Heather.
But we also are so thrilled, and we thank Jen Gardner for being part of this process with us. So I think it's important to say that she's not just here tonight just to share. She's part of the process of thinking and learning, and for us to try to learn more about that. And Jen, thank you. She brings back examples from the class. She's tried different parts of this. I really feel that this learning that we've done together with Heather and Jen is really about how do we go next with our early math development. And we're really digging deeply based on where our students are at. And of course, Mary Lynn, we appreciate her constant being with us. And I'm Ben. So there we are. Let's jump in.
I moved the slide forward for you, Ben. It sounded like you wanted to head forward. So here we go. Thank you. And I also would like to just very briefly say thanks to Jen, because as Ben said, she's been a big part of how this particular session will have developed. So I really appreciate her help trying things out in the classroom. Because I don't have kindergarten age children anymore, so it's a little harder for me to try these things out. But I know that they would work, and she tried them out for us. So here we go. In this series so far, so this is like a 3-part series that we've been doing along with Jen and Mary Lynn and Ben, and we've been looking at this piece of Dr. Lawson's continuum. And this piece here is not actually in her original book, but this is a bit of a prequel or an addendum, except it comes beforehand. We're still searching for what that word is. But this little piece that she's tapped onto the beginning to help us understand what students need before they are ready to add or subtract. And so we've looked at subitizing in our first webinar in this series. And then we looked at the 3 parts of counting that are required for accurate counting. And we also looked at a couple of the key ideas down here in the blue that support students to understand how many. So we've got cardinality, which is one of our key principles that students need to develop. And then the need for organizing and keeping track. So that's what we've looked at so far. And so now, if you've been working on these things in your classroom, or you have students who kind of have a handle on these, at least with some small numbers, the next step is that we want to talk about is how do you transition them from these areas to adding. So what do we do to help move them from this pre-addition area into actually doing addition and subtraction? So that's what we're going to look at in this session. Before we can look at how to move students, we have to maybe do a little bit of professional digging for ourselves. Some of you, this will be old hat, you'll know this already, and for some of you, this will be new information, but we do have to look at the additive problem types. And additive problems, an additive problem is something that has a story that has an additive relationship between the numbers. And it actually means it can actually require addition, or you could, in some cases, you can use subtraction to find the relationship between the numbers, but they're all called additive problem types. Just, I don't know if that's just to be confusing or to shorten it up, but they are all called additive problem types, even if they require subtraction. So a lot of folks in Lambton can't have access to Dr. Lawson's book. So if you do, this image that I'm looking at right now is actually inside the book on page 80. And the original work that I'm familiar with, most familiar with, and that this table comes from was actually done by Thomas Carpenter and his research team. And so sometimes these are called Carpenter Problems, named after him. And the way he categorized problems was a lot by how students thought about it, would think about these problems. So he has these additive problem types, and if you count them up, there's actually 11 different additive problem types that he identified. And there's two main categories of problem types. He's got some that have actions in them and action problems, and then he has some he calls relationship problems. So the two action problems are either join or separate, and the two relationship problems are either part whole or compare. And in addition to that, he also identified that where the unknown is in the problem is really important for educators to understand, because where the unknown is can definitely increase the challenge of a problem, and it can also make it can also support them to have to actually think differently. And we'll kind of get into that in a minute. So you can actually help to shift a child along the continuum because you ask them a different problem type, because they aren't able to use the strategy that they used to use on this new location of the unknown. All right, so basically in this table, more or less, the problems get more challenging as you go down the table. So join is our easiest type of problem, and it goes from there. And then they also get more challenging as you go from left to right. So if I look at the location of the unknown, there are 3 different locations that we talk about. We talk about the result being unknown, or the change being unknown, or the start being unknown. And that can be a bit tricky to think about, but in the result unknown, I'll just read the problem she has here. You have 5 gummy bears, your friend gives you 7 more. How many gummy bears do you have now? That would be a pretty common type of problem to ask. And then the change unknown, you would have 5 gummy bears and your friend gives you some more. Now you have 12. How many gummies did your friend give you? So that one, you don't know what the change has been from the original amount to the total. And then with the start unknown, you actually don't know the beginning of the problem. So you have, you might say you have some gummies, your friend gives you 7 more, and now you have 12. How many gummies did you start with? And we're not going to get into the start unknown ones, but I do have some very hilarious video footage of my youngest. I asked her a problem like this start unknown because I had already done some change unknown with her, and she literally has a temper tantrum on film saying that's impossible and you can't solve it. So
I hope we have time for that one.
Yeah.
I know. I have to dig through the archives and find it. Yeah. It's
director's cut of this session.
Oh, she can have a bit of a strong personality. So we're actually only going to look at 4 from this chart tonight, and they're the 4 most common ones that we want you to maybe try out. So the first one we're going to look at is this result unknown, this join action. So with the joining action, you're taking two groups and you're putting them together, and therefore joining. The second one we're going to look at is this one called a separate result unknown. So the separating action, so you're taking away or some kind of action that requires separating, giving some away to a friend or something like that. So you're separating the original set. The third one that we're going to look at tonight is this change unknown. It's going to have a joining action in the problem, but you're not going to know by how many. They're just going to know the total. So that's the third one that we're going to kind of look at tonight. And then the last one that we're going to look at is this compare difference unknown type of problem, which is down on the bottom of the chart. And I didn't get into these ones too much, but you're basically comparing two different groups, and you want to know how many more you have in one group than the other. And it can also be how many fewer you have in one group than another. That's a lot harder language. But we can't just jump from our little, 3-year-olds and 4-year-olds who can count or do some subitizing all the way to those big wordy story problems. So some of you might be sitting there thinking there's no way they're going to be able to handle that all in one big jump for some of them. So how do we support children to be able to get in on those full-blown story problems? Well, we start with like a bit of middle ground that's called extending how many. So extending how many it looks like this. The child is already working with a collection of objects. So they already have some objects in front of them. And then the educator explores how many with them. And then they extend from that collection or a series or a group of collections sometimes to a mathematical situation involving that same collection. And this is different from story problems because with a story problem, the child is not already working with a collection of objects. You're asking them this problem kind of out of the blue. You pose the whole problem at once, not in pieces. So those little word problems that we were looking at on that last page, you would say the whole thing at once and try to not break it up for them. And then the child would use drawings or a type of manipulative to represent the items in the problem. And in the true form of story problems, those items would not be the same ones that would actually be listed in the problem. So they might use cubes to represent stickers, or they might use a drawing to represent a person or something like that. All right, so we're going to look first at how to use these extending how many situations to addition and subtraction. So we have this little graphic at the top to help us remember which type of problem we're working towards. The ones that you're going to see here are not full-blown story problems. We're really doing those extending how many, but they're related to the thinking that's involved in these different types of story problems. It kind of sets them up to be able to think mathematically in this way so that when we do ask a full story problem, that the students might be better prepared. So for these join result unknown, extending how many situations, the educator is going to look for a student who is playing with a collection of items. And then the educator might ask something like, can you tell me about what you're doing? And then if they talk about the collection, then you can ask them, do you know how many of whatever that item is that you have? So I think we're going to see one with cheetahs. So you'll hear Jen ask, do you know how many cheetahs you have? Then the educator has a decision to make. They have to select an appropriate number to join to the set. So they're going to be thinking about who the child is and a number that they think that they might be able to handle. So they might say something like, if I gave you, I think Jen says 2 more cheetahs, do you know how many you would have then? Or something like that. So you're going to give them a number and you're going to ask them if they would know how many they would have if they added, joined 2 more to that set. All right. So here we get to here, and I think I forgot to share properly, so I'm just we're gonna have to pause for 1 second. I'm so sorry.
This totally makes sense though, because in kindergarten classrooms all the time, how many times do we see, Jen, a student grab a bunch of something, right? Cars, whatever they're interested in at the time, right? Dinosaurs, blocks. It doesn't have to be like, figurines or anything. Sometimes it's just items.
It can be anything.
Rocks, marbles, anything.
Buttons.
Yep. We have all that stuff.
All of the above. And cheetahs.
All of it.
And cheetahs.
And cheetahs and other feline-ish looking animals.
I know that they're not all cheetahs, but the boys had told me that they were all cheetahs, so I went with it.
Yeah, it's really up to them. They could have been lumps of clay and they could have called them cheetahs and you'd be like, cool.
Cool. Look at those
Right.
cheetahs.
Yeah. All right, here we go. We're going to watch them and listen to Jen and the boys.
Can you boys tell me what you're doing here?
We're playing with animals and we're making stuff.
Oh, I can see that you have some cheetahs there. How many cheetahs do you have?
4.
If I gave you 2 more cheetahs, how many cheetahs would you have?
6.
All right. So Jen, tell us a little bit about what you saw there with those students.
So they were just playing in a group of 3 originally, and when I got the camera out, it went down to 2 real quick. And they were playing cooperatively together, but I noticed that they were lining up some animals that looked similar. So I thought that it was a good opportunity to do one of my math problems with them. And the one little boy was very fast to shout out the answers, and he's correct. And I did notice his friend really wanted to know what he knew, but he perhaps needed some extra time. So with those 2 boys, I probably would pull the one that really wants to know. I'd pull him aside and maybe pose the same problem with different numbers, obviously, and see what he could come up with if I gave him a little extra time. And the other one, the problem was too easy, so I would make that a lot harder for him.
Yeah, he knew those numbers cold. One of the things I noticed is that they're subitizing that set. Was the one who yells out 4 though? He is the second boy, right? The one who takes a little bit longer usually.
Well, I
right here.
They both said it. You can't hear it as well, but the first boy says it quieter first, and then you hear the 4 after, like a little echo.
Okay. Yeah, it's a little hard to tell. So yeah, but what I notice is that the one who's saying it first is subitizing and not counting, but you can still, these questions work equally well with subitizers as with kids who are counting. So depending on the size of the set. Yeah, thanks for sharing that. So we're going to take a quick little look here at what progressed in that problem or how to analyze what your student might be ready for. So did they give the correct answer and it used a correct action? I was thinking about this particular box afterwards, and I'm not sure if they would give a correct answer if they didn't use a correct action. So anyway, if they did that, then exactly. I don't know. It's a little redundant, but anyway, and the action meaning the action in the problem, right? They whatever they were doing to try to sort it out is what they would need to do. So then try with some higher numbers. That's what you said, Jen. You might try with that boy who knew this cold and didn't have to think about it too much. You might try with some harder numbers. You could try a harder problem type. So as we go through tonight, each step along the way up until compare difference unknown is going to be harder than this kind of join situation. And you could actually, I think with him, you could try a straight up join result unknown story problem because he's probably ready for it. He can probably hold all those things in his head. So I'd be interested to hear if you did one, if you'd be able to do it.
He can. I did it later.
That's right.
Good to know.
Surprise.
More on that in another webinar.
Yeah, that's right. More on that. Tune in next week for what happens next.
No. Yeah.
Did they give a correct answer? No, let's say they didn't give a correct answer. So they gave an incorrect answer, but they did use a correct action. So this can particularly happen if they're using some counting strategies, and they might join the 2 sets together in some way, but then when they do their counting, they actually gave an incorrect answer. They didn't count it correctly the second time. So you could try that with lower numbers. If they have the action correct, then really it's probably just about their how many skills that just need a little bit more work to develop. So they could probably get a correct answer with lower numbers here. So keep working on that, those how many skills, but in terms of their problem solving, maybe with some lower numbers. So then if they get, that's not what they did, then they would have given an incorrect answer and maybe used an incorrect action or no action. They weren't really sure what to do. If that's them, then one of the key things to do there is to invest a little bit more time developing the story so the child understands them better. And in the case of working through play, it would actually be about trying to find the child interacting in a situation that's maybe a little more conducive to the join result unknown question. So, you know, instead of it just coming out of the blue and not being related to how they're actually playing or thinking about those objects, it would make more sense if it was maybe a bit more tied into the actual context. I don't know if that makes sense to you, Jen. I was thinking about like if they were playing store or something, and so they were already like combining sets by buying more of something, or other situations where they might actually be, the joining action might be a part of their own play.
Definitely.
Yeah. So that's what I would recommend there for students who don't understand the what you're asking, is to really try to find, you'll have to take a little bit more time with those students to connect your questioning to what they're actually playing about.
So the intentionality of those next steps are pretty interesting. Like, would that be something you had in your practice before, Jen? Because you have pieces of this, right? Like I've seen you in your class asking similar types of questions. I guess that's what I'm wondering.
I think knowing that there are so many more problem types than just the ones that we think we know, I've definitely gained a way better understanding.
Yeah.
Speaking of, that's a nice segue, because we're going to head away from that join result unknown, which is probably one of the ones that you would have done most regularly, right, Jen?
Yeah, definitely.
Yeah. I mean, I'm pretty sure if we could raise our hands here, that would be around the table. Yes. By far the most common. So let's extend our personal comfort zone on our different problems that we can ask.
Hang on.
So here we go. Separate results unknown. So we've got the educator who looks for a student who's playing with a collection of items. So this part's the same. You're still just looking for kids playing with stuff. That should be easy enough. Can you tell me what you are doing? Same first questions. And do you know how many of whatever that is that you have? So I think in this video we're going to watch, it's blocks. So do you know how many blocks you have? And then you have to select an appropriate number to separate from the set. So you're going to take away. So in this case, we're looking at a child with 7 blocks, and Jen, you opted to remove 2. So that's going to be part of your questioning. So you could say, if you gave me 2 blocks, do you know how many blocks you would have left? Okay, here we go.
Hi, what are you doing with those blocks there?
Counting.
Counting? How many blocks do you have?
1, 2, 3, 4, 5, 6, 7.
7? If you gave me 2 of your blocks, how many would you have left?
1, 2, 3, 4, 5.
How many?
5.
All right, Jen, tell us a little bit about what you saw there with this student.
Well, this is a little JK student, and I thought maybe I'd have more dialogue, that we would struggle with this a little bit. And She knocked it out of the park. She was awesome. She didn't remove 2 blocks, which I thought was really interesting. And I was really impressed that she was able to stop herself at 5. I thought for sure she was going to tell me 7 once again, but she didn't. So she was able to visually take the 2 blocks away without physically doing it.
Yeah.
And it was pretty eye-opening.
Yeah, because it's only 2, she can subitize those 2. And so she can see those 2 and not have to move them out of the way. You know, if it had been a bit of a bigger set and you'd asked her to remove a bigger number, you probably would start to see that. But with such a small number, and the fact that it's subitizable, it probably doesn't hurt that those 2 happen to be rotated a little bit too, right? That helps with the subitizing of those 2. I don't know if that's purposeful on your part or fluke, but it's beautiful.
I'm wondering if that's how I came up with 2. Maybe that was a subliminal message
She was.
to myself.
It might have been why 2 jumped into your head as being something to remove, because they were there for you. But I think in this case, I mean, that's a nice, you know, it helped her out probably that those 2 were rotated in that way, so she could keep them clear in her mind about which 2 it was going to be. And then she does a nice job, you know, counting the rest of the set. And I love that you ask how many at the end, just to make sure that 5 is not just a count.
I might have learned that from
So
you.
trust the count, and that would be, if I'm going to apply my learning ahead, that's cardinality.
Yeah, that's the beginning of cardinality. The fact that she knows that the word 5. Yeah, good for you, Ben.
Yeah, good.
Gold star. I think I can actually find one of those on my annotate tools. All right. So there we see, you said JK, that's pretty, you know, the separate action can be a bit tricky. I've asked full-blown word problems to SK students, and many of them can't do the separate. And I wonder if we had known about these, you know, extending their thinking to these mathematical situations in advance of doing some of those diagnostics, if it would have helped them. I think it would have. So this part's going to be pretty similar to the last one. Did they give a correct answer? Yes. Try higher numbers, try a harder problem type, or you could try the full separate result unknown story problem. Did they give an incorrect answer, but their action was correct? So if she had, you know, accidentally counted only to 6, or if she'd pulled away 2 cubes and then counted the set and only come up with 4 or something, then you could try it with lower numbers and see. These were fairly, you know, low numbers that you were working with, and the rotation of those cubes didn't hurt. And then, did they give an incorrect answer? So in this case, if that had been yes, it's sort of this. This part's all kind of the same. You invest more time in developing the stories so they really understand the action. According to Carpenter's research, the reason why these join and separate problems come first is because the action in the problem helps young kids to figure these things out. And so we really have to just invest more time in the story, or find a play that would lend itself more naturally to a separate situation. And then, like dropping kids off at daycare in their play, or you were telling me one day they had the school bus going, so maybe people are getting off the bus, you know, and that might help that type of scenario. So they had built a school bus, I think, in your classroom with chairs, and they were getting their friends to ride the school bus. So then when maybe kids get off the bus, you could play a separate kind of extension there. And then you could ask an easier problem type, because now we do have an easier problem type, which is our join results unknown. So we could go back and ask a different kind of problem with that student. All right, we're heading up down the line. We got join change unknown coming. So this is like probably one, I don't know, Jen, you tell me, had you asked this kind of problem before?
No, I wouldn't have asked this before. I would have thought it was too hard, to be honest.
Yeah, it feels hard, right?
Yeah.
Yeah, so we're going to take a look and see how they do with it. I hear that a lot, actually, from educators of young children, that they would think this one would be beyond the kids' abilities to think about. So what you do with this one starts out the same way. You look for a student who's playing with a collection of items, and the same initial questions. Can you tell me about what you're doing? Do you know how many whatever items you have? I think we've got 2 different videos to look at for this one. We've got some dinosaurs and some shells. And then you would select an appropriate number as the total number of items. So let's say they were playing with, I think in the one with the shells, did he have 11 shells, Jen?
Yes.
Yeah, so we had 11 shells, and so you picked 16 as the total number. So they already have 11, and you picked 16, and you thought this student could do it. You didn't pick a number that you necessarily thought that they would know right away. Is that right?
I was trying to trip them up a little bit.
Yeah, just to see what we would get. So if you want to build confidence, you would pick a number that you think they might be able to figure out, like maybe, 12 even. Do you know how many more you'd need if you needed to have 12 or 13? But if you want to push them, if you want to give it a try and see, you can pick a number that you're not sure. Maybe they'll know it, maybe they'll be able to figure it out, maybe they won't. And so then you would ask, if you wanted to have, and you said 16, do you know how many more shells you'd have to collect or to put in your collection? And we're going to actually watch the dinosaur one first. So I think the dinosaur one is the dinosaur one 4 and 6 also? I think they have 4 dinosaurs and they want to have 6 maybe.
There's a 7 in there somewhere.
Oh, that's what it is. Yeah, that's right. He has 3 dinosaurs. And do you know how many you would need to have 7? So we'll take a look.
Can you tell me about what you're doing over here?
I'm playing with the dinosaurs, and I made a home for them.
Oh, how many dinosaurs do you have?
3.
Do you know how many more you would need to have 7?
4.
4 more.
I should say here too, Jen, that when I originally sent you the questions, I didn't say, ask, how did you know? And it made you a bit itchy. And then when we watched them back, we talked about the fact that we both wanted to ask, how did you know? So you can certainly throw a how did you know at the end, because it would be interesting to know how he was thinking about it.
Definitely.
Yeah. Oh, I shouldn't have gone forward yet. So what did you see in this, when you're doing this interview, Jen?
Well, like I said, I thought it was going to be too hard. So I kept it fairly simple, still thinking that he would struggle a little bit. Mm-hmm. But then all of a sudden he was so fast to come up with the answer. Then I'm like, I guess I could have done that a lot harder for him. In the next video, that's why I used higher numbers.
And is it the same child with the shells as we saw here at the dinosaurs?
They're different.
Different kids, yeah. So, I mean, pretty spectacular. He's doing a fantastic job. We don't know exactly how he knows 7, but he has that part-whole relationship down because he's not counting to figure that out. So he knows the relationship between 3, 4, and 7. So, here's the one with the shells. So you went for bigger numbers. You're thinking this one's going to trip them up for sure. Yeah. Yeah.
I see you have some shells there. Do you know how many shells that you have?
1, 2.
11. Do you know how many you would need if you wanted to have 16?
Yeah.
How many more would you need?
I think you would need 5 more.
You think you would need 5 more? How do you know? Were you just guessing, or were you doing that math in your head?
I was doing that math in my
You were doing that math in your head? Oh my goodness. Well, can you check to see if you're right?
Sure. I'm right.
You're right. How many more did you have to add?
5.
5 more. And then how many did you get?
16.
16 altogether. Wow.
I love how enthusiastic you are about his work too, Jen. That's fantastic energy.
Well, it makes them work hard.
He's a silent counter, so that's tricky, right?
Yeah, I was really confused what was happening because he started counting out loud and then it went silent. And then he kept popping up with the right answer. So I'm like, should I pose the question again? Or it's hard for me, but I was quiet about it and just let him have that time to think.
Yeah, I'm not sure how he came up with 5 because he pulls his hand away from the floor. So I do wonder if he's kind of tracking you. You know, we can't really see his fingers while he's figuring it out, but he does come up with 5. He thinks it's 5. He's not 100%. And then when he adds the 5 to the collection, I find it interesting that he doesn't automatically go and count. So I'm wondering if he's actually counting on as he's adding those 5 by saying, like, in his head, 12, 13, 14, 15, 16. I'm not sure because he's a silent counter. So it'd be a lot easier if he would say them out loud as he put them down. We don't know for sure. So, you had him count the collection just to be sure.
He's a really confident counter too. Like it's silent, but even the way he manipulates it with his hands, and some of the shells are inside shells, and he does some things that are really, really quite fascinating, I find, in his counting. So, and the other thing I find amazing is that we have thought all along, and Jen thought going in, and certainly I did too, and that these would be too hard, and it wasn't too hard for any of the kids, for any of them. So we're actually at a place where we need to use harder and bigger questions with them, or harder questions, different types, right? So
yeah, your kids might be ready for the full-blown story problems in some of these cases. Certainly those two with those numbers. As you get harder numbers, it becomes more challenging. Did they give a correct answer and use a correct solution? So that's a yes on both counts here that we saw. So you could try some higher numbers. You can try a harder problem type. And you can try a join, change, unknown, full-blown story problem. If they're not correct, do they use the right action? Is there a joining action in there? And if yes, then but they're just counting incorrectly, then you could try working with some lower numbers and maybe continue to work on those how many skills, because it's probably those ones that are kind of getting in your way. And then if not, did they give an incorrect answer and use an incorrect solutions to the wrong answer? Yes, then really developing those change unknown stories is helpful. Probably in that case, asking some of those easier problem types and using lower numbers, easier to manipulate, would help them out. I see some stuff going on in the text chat there. I don't know if you guys are watching that or if there's a question.
No questions. Maria just had to head out, so we just said that we'll post the archive a little later this evening.
Okay, perfect.
But if anyone does have any questions at any time, please post them in the chat room, where Heather's happy to answer any questions that come up.
Yeah. So moving along then, we're going to head towards compare difference unknown. So this is where they do start to get a little bit different. This is our most challenging additive problem type. the compare problem type. The difference unknown is the easiest of the compare problems, but it's still fairly challenging. And in this case, the educator is looking for a student who's playing with two collections of items. And they have to be sort of a reasonable size that the student might be able to compare. And you might say, can you tell me about what you're doing, as we hear Jen do? And, you know, I see you have, for example, the one that we're going to look at, I see you have some orange dogs and some white dogs, that she might say that, something to that effect. And, you know, do you know how many orange dogs you have? Do you know how many white dogs you have? Which do you have more of, orange dogs or white dogs? And how many more orange dogs do you have than white dogs? So the whole first part is a bit of a setup for that last question. How many more orange dogs do you have than white dogs? And that's kind of the question that we're shooting for. I chose to put the specific example in these texts, these little text boxes, whereas before I just had like a generic one, because it gets a lot more complicated with these double sets. So I thought it would be easier to just have an specific example to work from here. So we're going to see Jen and her student. Oh yeah, that's right. I did add this little bit. You can ask how many fewer white dogs he has than orange dogs, but that language is a little trickier. But also sometimes you do get that in later math, so that's helpful. All right, so here we go.
Can you tell me about what you're doing?
I did 3 and 5.
3 and 5. I see that you have some orange puppies and some white puppies. How many orange puppies do you have?
5.
How many white puppies do you have?
3.
Do you have more white puppies or more orange puppies?
Orange.
How many more orange ones do you have?
If I add all of
Yeah, how many more orange?
8.
That's how many you have all together. You told me that you have more orange ones. How many more orange ones do you have? How many?
2.
2.
All right. So this one, Jen, tell us a little bit about what you saw there.
This one was much harder. I had come across, and it was a perfect example for it. However, she was really struggling with the empty spaces. She really thought I wanted to know how many altogether, probably because that's one of the ones I've asked in the past. And she does give the correct answer, but what you can't see is eventually she looks at the empty spaces and looks at me, and I'm trying not to give her any clues. And finally, under her breath, it's really quiet, but you hear 2. And then I ask her again, and she says it with a little more confidence, 2. But it was really hard for her.
Yeah. It is a perfect example, because one of the ways students will solve this problem is with a strategy that they call matching, where they take the two collections and they line them up to match the ones that are the same amount, and then looking for that difference as being these sort of 2 puppies here on the end. And so she's looking at this empty space here of where the white ones would be and how many puppies would fit there. So it's really interesting, and I think probably helpful too, that she already had these puppies set up in like a matching kind of situation. They don't have to be done like that, but this probably helped her to be able to really think about these missing puppies here. All right, so with this one, this is all kind of very similar. Did they give the correct answer and use the correct action? So then try higher numbers or a harder problem type. Try a full-blown story problem. If not, then did they kind of know how to get in on this problem? If yes, they started trying to match, but they kind of got the wrong answer, you could try it with some smaller numbers that they might be able to do on their and set it up this way. Or you could look for a situation where they've already got some matching going on, like what you got there. Did they give an incorrect answer and use an incorrect action? Well, there's lots of easier problem types to do. And I was actually thinking today, I don't know if there are any good books out there that would set up this kind of compare problem, but if not, we should write one, and then we could put a little bit more story behind it, and that might help them out.
Jake Kelch has a question here, Heather, saying perhaps the wording in the question, adding the word "than white" after. Being suggested.
Yeah, you could. How many more? He means how many more orange dogs do you have than white dogs? Is that what he means?
I think so. Maybe if you want to clarify in the chat, that'd be great. Yes.
Yes.
Yeah. Yeah, perfect.
Yes.
Yeah,
Yes.
that might help them for sure. That just a little bit of wording, and when the wording is new, Jen, it's not easy to kind of feel like you're comfortable in that skin yet of the wording for these different problem types that you haven't done yet.
Yes, and trying to stay to the script so that that was difficult for me.
Once it becomes your own, then you make your own script, right? So. All right, so we've just got a few more minutes left, but we wanted to look at extending how many to multiplication and division. I usually get a little bit of surprise from kindergarten educators when I suggest that we might start looking at multiplication. Full disclosure, multiplication is my jam, so of course we should start in kindergarten and preschool. So here we go. We're going to start with some equal groups, looking for some collections where they have equal group situation going on. And Jen, we'll throw this in here. You actually set up a provocation that you thought would probably bring out equal groups. So what did you do for that?
Yes, I did that by purposefully placing an equal number of snowflakes out as an activity on that morning, just to hopefully provoke the video I was looking to tape.
You mean the math that you were hoping to be able to generate,
yes,
right?
all of the above there.
Types of snowflakes?
Two different colors.
Oh, two different
Okay.
colors.
Okay.
Okay.
Yeah. So again, I thought we would use the exact words in here because it gets a little bit confusing. With the equal groupings, the wording is a little more challenging than with the other one. So can you tell me about what you're doing, which you do such a beautiful job of? I see that you have two different colors of snowflakes there, for example. You could say something like that. And then how many snowflakes do you have of each of those colors? Or you could have them, count them separately. Do you have two different colors with 8 snowflakes of each color? Do you know how many snowflakes you have all together? So asking that sort of multiplicative question at the end with the 2 groups and the how many of each is kind of the wording we're going for. But it's hard to get all that in when you're just doing it for the first time, I think, Jen?
Yes.
I thought you did really well, with these new words to kind of wrap your mouth around. So I appreciate you allowing us to share on this early stage of your journey asking equal groups problems.
What are you doing there?
Playing with snowflakes.
How many do you have in that one group there? It looks like you have 8 snowflakes in 2 different groups. How many snowflakes do you have all together?
First I need
I love that she has to finish her own play, right? That's how play really works. They have to do their own thing
Little
first.
snowflakes turn into big snowflakes.
Oh, all right. How many do you have all together?
16.
How many?
16.
Ooh.
Nice. And you asked the cardinality question there at the end.
Mostly because I wanted to make sure that I heard correctly.
Yeah, because her counting sequence is a little bit hard to hear for some of them. That's great. So thank you so much for asking that question. So sorry, what did you see there, Jen?
It was really interesting, her need to sort, and I thought we were going to sort all over that black paper there for a while, but she did end up being okay with it in each corner. And then when I asked her how many, she really needed to line them up. I was almost hoping she was going to line them up side by side, but she didn't.
Make a little array.
Yeah.
Maybe another time. There's probably ways. You're just going to keep getting creative on ways that you're going to generate that. All right. So this is pretty similar. So did they give a correct answer? Use a correct action? Yes. So again, higher numbers, harder problems. Try the full multiplication story problem. Higher numbers, you could have more groups, or you could have, and if I did more groups, then I would have smaller numbers inside the group, just to keep the counting reasonable. If not, did they give an incorrect answer but used the correct action? So did they know they were really trying to join those sets together but just counted incorrectly? So you could try that with lower numbers. And if not, did they give an incorrect answer and use an incorrect action? Then maybe they did that. And so then some little bit more investment into the story. So these are all sort of very similar each time. Try some smaller numbers, try an easier problem type. Now I did want to say that with the equal groups problem, even though we put it over on this edge of the screen, it's actually easier for students to do than probably even the join, change, unknown, especially with small numbers. So even though it's all the way over here on the right, we put it there because it's heading towards multiplication, but it's actually certainly easier than the compare, and probably easier than the join, change, unknown for most kids. So keep that in mind when you're planning out your choices. All right, so just a brief summary of what we talked about today. So if you're working with kids in their playing, you can look for children playing with collections of objects, and then you could try to pick an appropriate extension for the student. So the type of extension, whether it's a join result unknown, a separate result unknown, join change unknown, comparing with the difference being unknown, or constructing equal groups. And it, of course, appropriate with whatever collection they're playing with, because some of these ones up here on the end, they have to be playing with a certain kind of collection. And then if they get the answer correct, be amazed at their brilliance, right, Jen? They are pretty good at these things, regardless of the fact that we maybe haven't asked them before. And, resist the urge. If they're incorrect, resist the urge to show them how to do it, but instead try again, maybe with smaller numbers, enrich the context a little bit, like dig into it and make it connect to what they're playing a little bit more, or try an easier mathematical situation. So one of these earlier ones, like a join result unknown or a separate result unknown. So that's what we've got for tonight. I did go over a little bit, but hopefully you guys found it useful. And thank you so much to Jen and Ben and Mary Lynn for helping out on this one so much. And thanks for joining us.
Okay, and where can you go to learn more? So we can talk to our colleagues, connect with a coach. We have instructional coaches in all the buildings in LKDSB, so we certainly welcome you to speak to them. Always can go to our blog, which is lkelempro.blogspot.ca. All of these will be archived on and many more. We have all kinds of videos and wonderful items, especially about math, but other items too. And you can always find a copy of What to Look For by Alex Lawson, which every single building in our board has several. Several. Yeah.
So watch those archive sessions. You know, Heather, just thanks for that. But we want to say thank you for taking the time tonight to be with us. That is so appreciated. I think I'm so encouraged with the depth of thinking, and as we keep emerging in this space, how it feels so interesting and so encouraging that we are trying to support our students the best way we can. And by practicing and trying, I think I appreciate Jen for that, that trying and the practicing. We'd love to hear from you though, at tinyurl.com/infusing2020. I try to make a good tiny URL, that's all.
Yes,
but please put in there for the feedback. So tinyurl.com/infusing2020 for the feedback on the session. See how it went, what you thought about it. And if you'd like a participation certificate for professional learning credits, please enter your information there and we'll get that emailed out to you promptly. So thank you for being part of the sessions, the 3 sessions that we've had about early math learning. This is kind of completes our set, but we're excited about engaging in more early years learning and engaging with all of our early years learning teams. So questions, go to the blog, join in another session, not next Wednesday because this is it, but connect with instructional folks in your buildings. And we've got Jay Kelch and Karen Kay for jumping in, and Carrie Lynn. We just want to say thanks for everybody who joined in, and thank you to Rod, the man with the plan in the back, who helps so much go so smoothly. And we will be, Rod permitting, posting this later on this evening as he's been recording the session. So Heather, we're indebted to you for being so willing to engage in the learning together with us. So thank you, Heather. It's appreciated.